In this video, I will derive the law of cosines. The law of cosines is the technique we use to solve obtuse triangles when the law of sines doesn't apply, when we don't have a known pair. To derive the law of cosines, we'll start with an oblique triangle ABC, which I have drawn to the right. We're going to choose a coordinate system so that vertex B is at the origin and side BC is along the positive x-axis. If we let x comma y be the coordinates for our vertex A, and I drop a perpendicular to the x-axis, creating a right triangle, because the coordinates of this point are x comma y, then that means that the bottom side of that right triangle I just created would be x, and the vertical side would be y. Well, since I've created a little right triangle here, that means that SOHCAHTOA applies to that small right triangle. So for angle B, the following would be true. Sine of angle B is going to be opposite over hypotenuse, so that'll be y over c. And cosine of angle B is going to be adjacent over hypotenuse, so that's going to be x over c. If I multiply each of these equations by c, it brings us to our next line that says that y is going to be equal to c times sine of b, and x is equal to c times cosine of b. So now I'm going to replace the coordinates for point A, which were x comma y, with c cosine b and c sine of b. Now our point C, because of how we drew this, has the coordinates A0. Side AC, we've labeled length B because it's opposite our angle B. We can use the distance formula to find the length of side B because it's going to be the distance between two known points. Point A that has coordinates c cosine b, comma c sine of b, and point C that has coordinates a comma 0. Remember our distance formula between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. So substituting our ordered pairs in, we get that side B is going to be equal to c times cosine of b minus a quantity squared plus c times sine of b minus 0 quantity squared. And now I'm going to manipulate this expression to derive our law of cosines. Our first expression squared here has a minus in between the c cosine b and the a. So I need to write that twice and multiply it out. And now in the next part, c sine of b minus 0 is just c sine of b. So this simplifies to be just plus the quantity c sine of b squared. So we'll multiply out this first pair, c cosine of b times c cosine of b will be c squared times cosine squared b. And then c cosine of b times a negative a will be minus a times c cosine of b. Multiplying again, a negative a times c times cosine of b will give us another minus ac times cosine of b. And then a negative a times a negative a, that'll be a positive a squared. With this next one that needs squared, there's not a plus or a minus sign. All we have is the operation of multiplication between the c and the sign, so we can square each one of these individually. This will be plus c squared sine squared b. We've got some like terms here in the middle that can be combined. I'm also going to do some rearranging, and I'm going to put my last term next to my first term. I'll make it my second term when I rewrite it. So we'll have b equals the square root of c squared cosine squared b. Now here's where I'm going to move that term up. Plus c squared sine squared b minus 2ac times cosine of b plus a squared. Notice that these two terms that I move next to each other now have a common factor of c squared. I am going to factor that common factor of c squared out, which will leave us with cosine squared b plus sine squared b. Cosine squared plus sine squared is one of our Pythagorean identities, and cosine squared plus sine squared is equal to 1. So really this is just c squared times 1, which is c squared. We get b equals the square root of, I'm going to move that a squared up front, a squared plus, this is now just c squared minus 2ac times cosine of b. And then if I square both sides, my square root's going to cancel out on the right, and we get b squared is equal to a squared plus c squared minus 2ac times cosine of b. This results in one of 3 possible forms of the law of cosines. In our work, we could have just as easily placed vertex A or C at the origin, and this would have given the same result, but with the variables rearranged. In our subsequent videos about the law of cosines, we're going to see all 3 versions and then apply them to some examples.